Hi everyone, this is the gas walkthrough for October 12th. I'm Philip Newman. Today I'm solving Bent Diagonals Sudoku by Bill Murphy. We have normal Sudoku rules, 1 to 9 in each row, column, and 3 by 3 box. Additionally, we have some lines in the grid, and these are not your usual diagonals. Instead, they bend in the central cell. So this is a bent diagonal, and digits cannot repeat along these bent diagonals, which, since they're 9 cells, means they contain the digits from 1 to 9. This is another one. And the reason I'm highlighting 2 of them, you'll notice both of these contain 1 to 9, and 5 of the cells are the same. So that means the other 4 cells in purple are going to be the same as the 4 cells in green down here. So that's kind of what we're going to end up with at the end, is a set of 4 digits repeated here, a different set of 4 digits repeated here, and then the last digit in the middle. Those are the rules. This one has some tricks to it. I'm actually going to read the comment I posted on Discord in our team channel. Bill posted this and in parentheses says, maybe too clever, but I definitely feel like we've definitely tried tricks like this before. And so I solved it and posted my time, and I said, see, this I would definitely try to get away with, so you could probably do with a second opinion. And he did get a second opinion, but it's on the edge of not being gas, I guess. It's something that you can definitely figure out by thinking about it. So we're going to go through that process here. Where do we start, though? We can actually get a lot of digits. We have a lot of odd digits in the grid, so let's look at them first. And I'm going to start with 9. The reason I'm going to start with 9 is because I know that's a good place to start. But because of the symmetry in this puzzle, you might be drawn to the fact that 9 is in symmetrical positions with itself. So that might prompt you to look at it. Where does 9 go on the bent diagonals? Well, it doesn't go in any of the corner boxes. So wherever 9 is on any of these bent diagonals, it's in the central box. And the only way to get 9 on all 4 of the bent diagonals is to put it in the central cell. So that is a 9. We aren't going to be able to resolve the rest of the 9s. They're in a pattern like this in some order. But now we're going to look at the other odd digits. So let's start with 5 here. 5 on this top diagonal. Can't go in those cells, can't go in these cells, can't go here because of this 5, and it can't go here because of this 5. So this is going to be 5. We have a 5 here now, and remember, these 4 have to be the same as these 4. We've already taken care of our 5 on this diagonal and on this diagonal. So now we need the 5 down here to take care of the other 2. 5 can't go here, or here, or here, so it must go here. And those are our 5s on the diagonals. And now we're just going to rotate. So 1 can't go in any of these cells on this diagonal, can't go here or here, must go here. And then up here, it can't go in this cell, or this cell, so it must go there. 7 on this diagonal, none of these, so it goes here. And up here, it's going to go in this cell. And 3 has to go here and has to go here. So that is all of the odd digits on the diagonals. I think we can get one more of each of these digits. Let's see. 3 in box 2. We have 4 3s looking into box 2. That means we're going to be able to place a hidden single there. This is going to be our 5. We've got 5s looking in. This is 1 and this is 7. Okay. That is all you can do with singles. So this is where the maybe too clever thing comes in. There are a couple of ways to approach this. I'm going to use that fact that we talked about, that these 4 cells are the same as these 4 cells, and see where that gets us. So let's look at the edge cells for now. we've got all of the odd digits. They're not in the corners. This one sees 2 and 8, so this is 4 or 6. This one sees 4 and 8, so it is 2 and 6. This sees 4 and 6, so it's 2 and 8. And this sees 2 and 6, so it is 4 and 8. Now, I said that these 4 cells have to be the same digits as these 4 cells. Well, there's a 4 or a 6 in this cell, and none of these are 4 or 6. So this must be where that digit goes. It must go right there. Another way of looking at it, where this digit, whatever it is, doesn't go in these cells because they share a diagonal. And so it must appear in this cell. Likewise, the 2 or 8 must go in that cell. This 2 or 6 must go in this cell, and then 4 or 8 in this cell. And that's going to kind of break us into this. I'm going to fill this cell in just so we can see it. But let's look at 4 in the cell. Where does 4 go on this diagonal? Look at it that way. Well, it goes in one of these cells. Those are the only 2 places for it. Because we've placed our odd digits, we have a 4 here, so one of these is 4. We also got that by looking at the corner cells. One of these is 4. So we can rule 4 out of this cell is the point. We can also rule 6 out of these cells, this cell, because where does 6 go on this diagonal? It goes in one of these 2 cells. So we're going to have a 6 in one of these, we're going to have a 2 in one of these, etc. So this is not 6 either, this is 2. And once we have a digit, the rest of it collapses. This is now 6, 4, 8, and 2. That 4 is here, and we get those. And now we just finish off with our remaining digits in the corners. 2 means that's 4, 2. This is 6, 8. This is 2, 4. This is 8, 6. We can fill in our remaining edge digits like that. And now let's look across here. We are going to have our remaining even digit in these cells. So we have all the odds in that column and row. So this is 8. This is 4. This is 6. This is 2. This sees 2, 4, and 6. So this is 8, 6 like this. This sees a 2. And now we're going to resolve the remaining odd digits. This is 7, 9 pair. We can't do that yet. We need our last even digit in this row, which is 6. So that's going to resolve the 5. And now 5 must go here in this box, which places 9, which places 9 and 7, which places 7 and 8. And we're going to do the same thing in the other direction. We need 3, 4 here. That's a 4. That 3 is going to get placed here with a 9, which places 9 here with a 1, places 1, and finally a 2. And that's the solution. So that step in the middle, however you see it, it's a pointing pair, basically. And if you don't know what that is, just unwind quite a bit. This is going to turn out to be a longer video. A pointing pair is just when you have a particular digit limited to 2 cells in a box that are also in the same column or row, or vice versa. The other direction is called claiming, but they're the same logic. Since these are the only 2 places 4 can appear in this box, it can't appear anywhere else in the column. So that eliminated the 4 here. Since these are the only places 6 can appear on this bent diagonal, it can appear here in the row. So it doesn't have to be boxes. It be any pair of houses. But hopefully that helped. I'm seeing on the Discord comments that this tripped a lot of people up. And, hopefully you learned something from it. But I hope you enjoyed it anyway. Let us know how you did in the comments, what you think about this type of advanced step in gas or just generally. I think we would be happy to do other videos on slightly more advanced stuff that we won't put in gas, but yeah, just let us know. That's all I have for now. See you next time.